Before we leave the concept of the tangent function, let's take a look at one more example. Example 7 says, if it is known that sine of alpha is equal to 5 over 13, or negative 3 pi over 2 is less than alpha is less than negative pi, and that tangent of beta is equal to negative square root of 3, where pi over 2 is less than beta is less than pi, find the exact values of the following. Part A says to find the sine of alpha plus beta. Part B says to find the cosine of alpha plus beta. And Part C says to find the sine of alpha minus beta. And Part D says to find the tangent of alpha minus beta. Now we've already looked at examples of A, B, and C. It's really Part D that's the new concept with the tangent, but we might as well go ahead and do another example of A, B, and C. In order to do those, we need these identities that are down at the bottom. And so to start with, it says the sine of alpha plus beta. We need to make sure that we know what the sine of alpha is, and I believe that that was given to us. So sine of alpha is taken care of. We need to know what the cosine of beta is. We do not know what that is. We do know what the tangent of beta is, but we don't know what the cosine of beta is, so we'll have to work on that. We need to know the cosine of alpha. Do we know the cosine of alpha? We do not. But we do know the sine of alpha, so we should be able to find the cosine of alpha. And then we also need to know what the sine of beta is, which again, we don't know much about beta other than the tangent. So let's see if we can find those first and see then which of those can then carry on to the other identities. So let me start with the cosine of beta. Let's start with that, and then of course we also know that the sine of beta is going to come from that. So we are given that the tangent of beta is equal to negative square root of 3. And we're also told something about beta. We're told that beta is between pi over 2 and pi. Now if you think about a circle and you think about that space between pi over 2 and pi, that puts me in the second quadrant. In the second quadrant, my cosine is negative and my sine is positive. And then the other thing that we know about tangent is that tangent is equal to the ratio of y over x. So not only is my cosine negative, but my x value would have to be negative. And not only is my sine positive, but my y would have to be positive. So if I take negative square root of 3 and I break that up into a fraction where y is positive and x is negative, I get the value of y is equal to the square root of 3 and x is equal to negative 1. Now using that information, I should be able to find the radius. So let me do that. I know that x to the second plus y to the second is equal to r to the second. And so I'm going to go ahead and substitute the negative 1 in. Don't forget the parentheses around that negative. Plus the square root of 3 squared equals r squared. So I get 1 plus 3 is equal to r squared. I like the looks of that number. So r squared is 4. That means r is 2. Now that's helpful to me because the cosine of beta is equal to some x value over r. Well, I just know that my x value is negative 1. That was given to me with the tangent. And then the r value is 2. So the cosine of beta is equal to negative 1/2. That's helpful because I'm going to need it over here with the cosine of alpha plus beta. Where else do I see cosine of beta? Looks like down here. And while I'm at it, I checked off the sine of alpha. That was given, so let me just go ahead through and check that off as well. All right, so we're doing pretty good. Sine of beta, I think our work also helps us with that. That's going to equal y over r. And my y value for beta was the square root of 3, or is the square root of 3, and my r value is 2. All right, so the sine of beta is going to be the square root of 3 over 2. So that helps me. Where else do I see sine of beta? It looks like I see it over here with the cosine of alpha plus beta. And then I also see it right here for sine of alpha minus beta. Now, what am I missing? It looks like I'm missing cosine of alpha. So let's direct our attention back over to this sine of alpha. We are given the sine of alpha, but we are not given the cosine of alpha. What we are told, though, is what quadrant we're in. So let me draw another circle here. Draw another circle. And alpha is between negative 3 pi over 2 and negative pi. Well, negative 3 pi over 2 is starting on the positive x-axis and moving clockwise. Negative 3 pi over 2 is in the same location as positive pi over 2. And then negative pi is in the same location as positive pi. So I am again, it looks like, in the second quadrant, quadrant 2, where I know that my cosine or my x values are negative and my sine or my y values are positive. So that makes sense to me because sine was given to me as a positive number, but that's going to help me to know that when I go to find the cosine of alpha, I'm going to expect that that is a negative number. Now, how am I going to find what that negative number is? Well, cosine, of course, is x over r. And what did 5 over 13 give me? In the original thing that was given, 5 over 13 represents my y over my r. So I've been given y as 5, and I've been given r as 13. So I know that the denominator in the cosine is going to be 13. But what's the x value? In order to figure that out, I've got to go back to my Pythagorean theorem of x squared plus y squared equals r squared. Now I could also use the Pythagorean identity where I had sine squared theta plus cosine squared theta equals 1. But since I've already broke this up into x's and y's and r's, I think I'll just stick with the Pythagorean theorem. So this gives me x to the second plus 5 to the second equals 13 to the second. So let's see, x to the second plus 25 equals 169. I'm going to subtract 25 from both sides, and that gets me 144. That's a nice number. So x is going to be plus or minus 12. And because I know that I'm in the second quadrant, the answer ends up being negative. All right, so I now know the cosine of alpha. And so I can check that off over here for cosine of alpha plus beta. Looks like I'm ready to go for part A. I'm ready to go for part B. Am I ready to go for part C? Yes, because I do know the cosine of alpha. That's good. And then for the tangent of alpha minus beta, I need to know what the tangent of alpha is, and I need to know what the tangent of beta is. Tangent of beta, remember, was given to me, right? That was given at the very beginning. But what I don't have is the tangent of alpha. But the tangent of alpha is simply the sine of alpha over the cosine of alpha. Well, the sine of alpha was given to us as 5 over 13. And the cosine of alpha, do we know that? The cosine of alpha, we said right here, is equal to negative 12 over 13. Instead of dividing by negative 12 over 13, I'm going to multiply by negative 13 over 12. And so the 13s cancel out, and I find out that the tangent of alpha is equal to negative 5 over 12. Now, this is a lot of messiness. I'm going to summarize this all on the next slide, and then I think we're set to begin on part A, B, C, and D. So from the previous slide, here's the summary of what we found. We found that cosine of alpha is equal to negative 12 over 13. We found that the tangent of alpha is equal to negative 5 over 12. We found that the sine of beta is equal to the square root of 3 over 2. And we found that the cosine of beta is equal to negative 1/2. Now remember, the original problem gave us some information as well. We knew that the sine of alpha was 5 over 13, and we also knew that the tangent of beta is equal to the negative square root of 3. And so let's take a look at part A and part B. Part A says to find the sine of alpha plus beta. So using the identity that's written down at the bottom, I need to know what the sine of alpha is. The sine of alpha was given to me as 5 over 13. I'm going to multiply that by the cosine of beta. The cosine of beta I found to be negative 1/2. Then I'm going to add that to the cosine of alpha, which is negative 12 over 13. And I'm going to multiply that by the sine of beta, which is square root of 3 over 2. It's really nice when you go through and you find all these values, and now we're just plugging them in. We're locating them and we're plugging them in. So let's see what I've got here. This is going to equal, if I multiply my fractions, I'm going to get negative 5 over 26. Looks like minus 12 times the square root of 3 is just 12 times the square root of 3, and that's also over 26. So since I have a common denominator here, I can go ahead and write this as negative 5 minus 12 times the square root of 3 all over 26. Now, I would totally accept that as an answer. I suppose that we could also factor out a negative from the top. In other words, pull a negative out to the side, and that would leave me with a positive 5 and a positive 12 root 3 on the top all over 26. I would accept either one of those answers. For part B, cosine of alpha plus beta, let's keep going. If I look down at the bottom, I see that the cosine of alpha plus beta is equal to the cosine of alpha, which is negative 12 over 13, times the cosine of beta, which is negative 1/2, minus the sine of alpha, and sine of alpha, remember, was given to us as 5 over 13, and multiplied by the sine of beta, which I found as the square root of 3 over 2. So I'm going to do that multiplication. Negative times a negative is going to give me a positive 12 over 26, minus 5 times the square root of 3, also over 26, which is nice. I'm going to go ahead and combine these together over that common denominator of 26. So I'm halfway done, got part A and part B done. Let's move to the next slide and we will tackle part C and D. All right, so I've gone ahead and included those values again for us, but instead of rewriting the problem, I just added the things that were given to us on the end. So in other words, cosine of alpha, tangent of alpha, we found those, and then this sine of alpha and this tangent of beta, those were given to us in the original problem. Now the reason I did that was because I have a feeling that I'm going to need the space. So let's go ahead and start part C, sine of alpha minus beta. The identity is down at the bottom. That is simply equal to the sine of alpha, which was given to me as 5 over 13, times the cosine of beta. The cosine of beta is negative 1/2, and I'm going to subtract from that the cosine of alpha, which is negative 12 over 13. I've got some double negatives there, multiplied by the sine of beta, which is the square root of 3 over 2. So if I simplify this, I get negative 5 over 26 plus 12 root 3, also over 26. So I will put those numerators together over the common denominator of 26. Not bad. Now for tangent. Tangent of alpha minus beta is equal to, so I'm going to just substitute in, the tangent of alpha we found to be negative 5 over 12, minus the tangent of beta was given to me as the negative square root of 3. And I'm going to divide that by 1 plus the tangent of alpha, which is negative 5/12, times the tangent of beta, which is negative square root of 3. Now, this is just arithmetic, but it's a little bit ugly. We've got fractions within fractions. So I'm going to start the process of making this look a little bit better. And I think in order for it to not look quite so confusing, I'm going to alternate colors between lines. Okay. All right, so up in my numerator, I have negative 5 over 12 minus a negative square root of 3. In order to actually do that subtraction, or I guess I should say addition, because those double negatives are going to turn positive, I would need to find a common denominator. I need to multiply that square root of 3 by 12 over 12. So that's going to give me up in the numerator negative 5 plus 12 square root of 3 all over 12. All right? Now, my denominator, if I look up there, I've got 1 plus, and let's see, it's going to be 1 plus negative, that's a 5. I couldn't even read my own writing. This is a 5 right here. That's a 5. If I do that multiplication, I get 1 plus 5 root 3 over 12. And 1 can be rewritten as 12 over 12, right? And so, again, I've got a common denominator. In fact, this part right here, if I had more space, I would rewrite it, but that part becomes 12 plus 5 root 3 over 12. Now, I want you to notice something. This is a complex rational expression, complex in that there's a fraction within a fraction, but both of the fractions in the numerator and the denominator are divided by 12. So I could rewrite this whole denominator as multiplication by the reciprocal, and that's going to cancel out those 12s. So here's what I'm left with. I'm left with negative 5 plus 12 times the square root of 3 all over 12 plus 5 times the square root of 3. Now that looks a lot better, but there is a radical in the denominator. So typically you're going to be asked to rationalize the denominator. And maybe it's been a while since you've done this, so let me go through it. In order to rationalize a denominator that is part of a binomial, meaning that this 12 and this 5 root 3, it's a binomial and that there's two terms. The technique that you should have learned in previous classes is that you multiply it by what we call the conjugate, which is 12 minus 5 times the square root of 3. Now if I do that on the bottom, I have to do that also on the top. And you'll notice that I put parentheses around it. That's because I want to make sure I remember to FOIL. Take first, outer, inner, last. Now it's going to be a little bit messy, but bear with me and just slow the video down if you need to go over it again. So starting in the numerator, negative 5 times 12 is negative 60. Negative 5 times negative 5 root 3 is positive 25 root 3. Now I'm going to multiply the insides. 12 times 12 is 144 times the square root of 3. And 12 root 3 times minus 5 root 3 is what? It's going to be negative, well, 12 times 5 is 60, and the root 3 times root 3 is just 3, so 60 times 3 is 180. That's what I have up on the top. Down in the denominator, 12 times 12 is 144. And the reason why we multiply by a conjugate is because by multiplying by one of them being plus and one of them being minus, there's my 144, I get negative 60 root 3, and then on the inside I get positive 60 root 3. So those two cancel out. I'm not even going to write them down. And now I'm going to multiply the last terms. So I'm going to get 5 times 5, which is 25, and square root of 3 times square root of 3, which is 3. 25 times 3 is 75. So I'm going to minus 75. And so you'll see down in the denominator, I have actually cleared that radical. The only thing left for me to do is to simplify. And I'm just going to say equals here because I'm running out of space. If I look up in the numerator, the like terms are negative 60 and negative 180. So combining those, I get negative 240. 25 root 3 and 144 root 3 add together to give me 169 root 3. And then down in the denominator, 144 minus 75, if I put that into my calculator, I get 69. Now, for this particular one, I do not think that, let me just circle this in purple, I don't think that this negative 240 and this 169 and this positive 69, I don't think that those have any common factors. But if they did, I would want to factor out the common factor and then see if I could reduce it even more. I've got a video posted within our course shell that goes into more detail on how to rationalize a binomial. So you might take a look at that if you need a little bit more guidance.